This is unit 23, I believe, in your book. And I'm just going to run through a couple things quickly. Mostly I want you to actually look through the videos that I'm putting on there. So if you are on Blackboard, you'll notice all these videos. And I really want you to look through these because it gives you a good breakdown of the different types. So I'm not going to go through all of the internal stuff, but I do want to just kind of do a brief overview of different types and their applications. I don't know if I meant to cancel that, but oh well. All right, so compressors. So the compressor is the heart of the system. It not only pumps refrigerant, but it also creates pressure drop in and out. So it creates a raise of the low side pressure. So as we've talked in class, you've got heat that's coming in from, that's in the refrigerant coming from the evaporator. So the evaporator has picked it up, mostly in the latent form of evaporation. So all that refrigerant has vaporized, kind of changed states, but still is very cold and low pressure. So in order to get the heat out of it, we have to raise the pressure of it before we can send it to the condenser, so it will be removed. The compressor does not change states of refrigerant. The compressor just changes pressure. So it's vapor in, vapor out. Low pressure vapor in, high pressure or hot gas coming out, discharge. So suction comes in, discharge goes out. I'm going to skim through this pretty quick. So one type of compressor is reciprocating compressors. These can be different versions of this, but basically what a recip does is it uses some sort of motor and a crankshaft to move some sort of pistons, one or more piston that's creating compression that way. Very similar to a car engine. Some of them actually are very similar. So this is an example of a reciprocating type compressor. And it might look kind of overwhelming. This is a cutaway if you look straight down it. And actually, we're going to go through not rebuilding, but tearing one of these down probably in class one day, just to kind of see what's going on inside of it. So these would be used for commercial applications. They may be big or small, but recips can be used on a variety of things. You're not going to see these on residential equipment. All the residential stuff is going to be hermetically sealed, which we'll talk about in a second. So in the middle of this, you got a crankshaft that goes round and round, and this one has 3 pistons that we can see. Let's see, let me pull this over here if I can get this animation onto the next screen. There we go. And so they're going to go up and down on that crankshaft and create compression up here in the discharge chamber. All right, so on these compressors, they have to have oil. Every compressor has to have oil for obvious reasons, to keep things lubricated. So one of the things we have to make sure is that the compressor keeps oil in it and that the oil is good. So if we have oil migration, which is something you'll learn about probably in your next module when it talks about reasons compressors fail. But one of the big ones is that they lose lubrication, the oil leaves and it doesn't come back, and therefore your moving parts start to break down. So on these, the way that these work, on the intake stroke, there's a valve that opens and allows low pressure vapor refrigerant in, and then on the this is a very drawn out process here. Then on the compression stroke, when this piston starts to drive back up, it creates compression, high pressure out, low pressure in, and there's a valve there that opens up as well. And so it's just a one-way, both of them are one-way valves, check valves basically, and discharges to the condenser. So this really drags this out. I'm going to skim through all that. Okay, hermetic. So hermetic compressors is just a Greek word for airtight container. Um, they have a welded steel shell, and they have some sort of internal springs, and they are suction cooled. So a lot of your motors are suction cooled motors, not all of them, but some of them, to where they actually use the suction gas to cool off the motor parts instead of needing something else. So if your suction gas is too warm, then that can cause overheating and so on and so forth. And if you don't have suction gas, you have liquid coming in, then that presents a whole other kind of problem. So this thing is a little bit hard to see what's going on. In my opinion, this one's kind of hard to follow. These are oblong looking. They're not cylindrical. They're just kind of a big tin can looking thing. And so you've got pistons and valves, but they are a little different in the way that they're laid out. Got a crankshaft, but it's like I said, it's still a little different. They are spring mounted and they are sealed, so you're not going to rebuild one of these. So I can honestly say I've never seen one of these cut apart. But it still has suction gas intake and discharge coming out. It's just doing it a little bit different. Then here you can see a cutaway of the motor windings. So here's your stator up here on the top. There you can see this copper cutaway over here on the side, and then in the middle there's your rotor. So that rotor is turning all these moving parts and doing what it needs to create compression. So suction vapor is coming down from your suction line through all of this moving parts, compression cycle, and out in the discharge. Semi-hermetic compressors. These you'll see some of these on a lot of different variety of equipment. Sometimes on coolers and stuff, you'll see these. There's different versions of those. So you can have air-cooled or water-cooled versions of those. So water-cooled would actually have a water jacket or a water loop going around it to cool it. So this might be used. That might be used in a place where maybe it's around a lot of heat. It's down in a mechanical room where it's very hot, something like that. It's obviously not going to probably be out on a roof that way, but a little bit different. Suction cooled compressors, like I said, they're using suction gas to cool off the motor parts. So inside of it, that refrigerant is going right over those motor windings. So if the refrigerant is acidic, as we'll learn later, that acid has a tendency to wear away the insulation on those windings. And that's what leads to one of the main reasons that you lead to early burnout, shorting winding to winding, shorting winding to ground. All right, so your electrical side, which we've dealt with in 130 somewhat in your electricity class, is the motor, the overload, and the terminals. Usually there's an internal overload of some sort. The mechanical part, you've got a crankshaft, pistons, valves, and a head. Here's another type, Coplamatic. I don't even know if they still make that anymore. So again, you've got to cut away. Here's your windings. Here's your rotor. Here's your piston. Just one piston on this. Here's your valves up at the top. And then that's going to be your discharge outlet. Crankshaft down here at the bottom. So there you go, ports of oil. So one of the things you may notice in some of these that are using one of these crankshafts, if we break one apart, is they'll have holes in there. And so they actually use a pump that's connected onto the unit or onto the compressor. And that pump, as it spins the compressor, also spins the pump all in one motion, all in one thing. So it's connected to the same moving parts that everything else is. And it picks up oil from the bottom and sends it through that crankshaft and then basically slings it where it needs to go through those holes. So on this type, you're going to have a sight glass. You won't have a sight glass on your scrolls and on your hermetic stuff, or usually you won't. But your semi-hermetics and these type of recips that can be somewhat broken apart. They'll have an oil level on them. They'll have sight glass, maybe 2 sight glasses, and usually in the middle is where they want that. And then you can see that this dip tube is going down into this oil. It's picking it up. This is your pump on the end, and that pump, as it spins, sucks up that oil, forces it through that shaft, slings it around to the places it needs to go there, and then it dumps back out the other end. So always refer to manufacturer specs if you're worried about sight glass level and stuff. All right, here's a picture of, there's a valve plate. There's a reed valve. We're going to see some of those in lab probably. So this has a valve plate. It has a head. So if you're familiar with car engines at all, which I'm really not, but it's actually kind of the same principle. I'm not a mechanic, but it's actually pretty similar. Here's your valve plate, and here's your head. So you got suction that comes in, discharge that works back through this plate on the compression stroke and forces it up into the discharge chamber, and then it works out the discharge line. So we'll see that better when we break that one down in class. Discus. Okay, so the Copeland discus is just a different version of a compressor. It's still a recip. It's kind of a brand they came up with. This is what we'll actually be taking apart as a discus in class, so we may kind of have a whole lesson on those just because we're going to be dealing with it. And so I'm not going to spend a ton of time, but basically you can see here, you got your compression stroke, vapor in, discharge out, and then that valve reseals. So on the top of it, you'll have something that looks like this, and that allows it to come and go, basically. Suction vapor comes in, allows that in, and then on the discharge stroke, it pushes it through. All right, another thing that's a little different about these type of compressors versus maybe the ones that we're dealing with in class is they have service valves on them. Those service valves don't usually have Schraders in them, and so you have this valve stem that you have to drive open. So these are going to be normally back seated, which means it's all the way back. You can see here, that allows nothing out of the hole. And these are weird when you're used to Schraders, because if you run into one of these and you put gauges on them, if you're not careful, you'll end up taking the gauges off without the refrigerant sealed off, and you'll end up blowing refrigerant everywhere. So you got to make sure that that's back seated. And then before you're going to read pressure, you have to push that seat or push that valve up into the mid-seated position. So you crack it a few turns to where it allows the gauges to read pressure. So you want to make sure your gauges are on there. And then front seated, you can actually use this if you need to isolate the compressor, kind of like we did a pump down on our systems. You can drive these up and it will completely close that off, pump it down, pump any refrigerant out if you need to. And you could actually remove that compressor, leave all the refrigerant in the system, put a new compressor in or rebuild this one or whatever, put it back in place, bolt it back up, pull a vacuum on the compressor. The rest of the system is completely ready to go. You just open your valves back up and you're good. So it's actually a big time saver. So discharge and suction valve service valves are something you're going to run into mainly in commercial stuff. Very few that I've seen on residential. I actually like them because you don't have a Schrader in the way, but people just aren't used to them, so you don't see them on residential stuff. All right, so like I mentioned, if you wanted to replace this compressor, you want to isolate this compressor, front seat the valves, pump out the refrigerant, old compressor is out, new compressor's in, pull a vacuum, open it up, and you're ready to go. I love it when I get ahead of where the slides are going. Compression ratios. So we're not going to get a ton into this right now, but essentially what this means is the ratio of head pressure to suction pressure. So how much it's taking in to how much that it can raise it. If you have, and it's absolute, not PSIG, it's PSIA. And so if it's bringing it in at 70 pounds and it's discharging it at 200 or whatever, then that ratio. So depending on your application and what you were needing that suction pressure to be. So when you get into coolers, freezers, you'll have a different compression ratio with those because you have to run a much colder evaporator, but you still have to keep your head pressure up above outdoor temps if it's air cooled. So you run a much higher ratio than you would if you were working on an air conditioner. All right, so here's some more types. This is probably more. A couple of these are going to be more familiar. Scroll compressors. So we've seen some of these in class. We have a lot of these. These and those hermetic recips are the two types you're going to see in residential. They're more efficient. They have no valves. They have fewer moving parts. They handle liquid a little bit better than a recip will if some were to actually get through. But essentially, it's a moving scroll and a fixed scroll. So this one here on the top would be bolted down to the housing. And this one on the inside is going to be actually attached to a motor that's on a little bit of an offset. So it's going to orbit, it's going to move, and it's going to rotate that refrigerant. It's going to rotate inside of the other scroll, and it's going to create less and less and less and less compression as it pushes this refrigerant through. So it's kind of interesting how they do it. So this is what it looks like. So you've got your suction phase, which is when it's drawing in vapor refrigerant, and then it starts to compress it as it works its way through. And then as it gets closer and closer to the center, there's less and less space for it to be. So obviously the pressure is going to raise, and it pumps it to the center where it gets to the discharge phase where it kicks it out. Kind of interesting. Whoever thought of this kind of stuff. That's a cutaway, but it's hard to see what's going on there. It really doesn't help a lot. Rotary compressors are similar, kinda. You might see some of these, like I think we've got a couple of these in the lab you'll see these on like window air conditioners and stuff. You won't see them on residential that I'm aware of, but I have seen them on window units. Kind of similar to a scroll. Centrifugals, these are going to be your big stuff. So centrifugals are going to be used on big chillers mainly. Here's what a chiller looks like if you've never seen one. So chillers are pretty interesting beasts. I worked on a lot of them at Moorhead, but I'm far from an expert on them. And so this has a centrifugal compressor on it, and you're going to have a chillers class next. You might have a chillers class in the spring. So we'll learn more about the details though. So I'm not going to spend a ton of time on that stuff because it's not really in the scope of the class, but I do want you to see them. So here's your motor on the end, and you've got an impeller, kind of looks like a big supercharger, and you're going to have a discharge line and a suction line, just like any other compressor. It's just set up differently. So this, to kind of give you a little info on a chiller, this is a water cooled chiller. So it has two water barrels. So you've got refrigerant. In this one here, we had something very similar to this at MSU. And these take water in the ends. So you've got water that comes in, water that circulates through, and then water goes out. So you've got chilled water and you've got condenser water. So chilled water is the water that you're cooling the building with. So instead of piping refrigerant all over the building, they pipe water over the building. So they cool the water here, and then they send that water all over the building to cool it or use it in process equipment or whatever they're doing. Usually that water's running 40, 42, 43 degrees out and back in at about 50 to 55. And so it's coming in and it's going through a set of tubes in this particular chiller. Some do it the other way around, but This one is refrigerant over water. And so inside of this, if you could cut this apart, there's refrigerant just inside of this barrel. And then there's water going through tubes. And that water goes in and it makes a few passes and it cools down and then it goes back out. And then on the condenser side, so your discharge pumps into the condenser over here. So here's your suction right here. It's pulling off of the evaporator. Pulls into the evaporator, slings it around, and then it pushes it into the condenser, which you can't see the discharge. And so it pushes it into the condenser, kind of does the same thing. It's got a water loop there that goes outside to a cooling tower just to cool the water off. So that water circulates through and removes heat from that hot refrigerant. And so it condenses the refrigerant there. So it's the same concept. It's just a lot different setup. Screw compressors. These are other ones you'll see mainly on large stuff. A lot of chillers. We had some screw chillers there as well. You can have different number of screws, but basically it's kind of similar to a scroll, and then it uses offset vanes to create compression through that. So it brings in suction, and then as it drives them through, it just creates an increase. So just kind of gives you an idea of the types of compressors that are out there. What we're going to get into, so we're going to make this compressors thing kind of a multi-week thing. So you're going to go through module 6, which is compressors part 1, and then we're going to get into some troubleshooting. We're going to get into why they fail, compressor failure reasons, and then the process of actually changing one out from start to finish. So this may go on for a few weeks, but compressors is probably obviously going to be the most critical thing to your system and probably the most expensive repair that they're going to be looking at. So you want to make sure that you do it right, and you want to make sure that you know how to diagnose them and how to prevent them from failing so quick. So that's pretty much all I've got for that. So be looking through these videos. Like I said, these videos will give you more information than I can. So check these out.